Daylight sometimes can be excessively bright and cause glare. But why facades are not often designed for preventing this? This is the question I'm asking to Giuseppe today. Let's go.
Oh, wow, it's so bright. I don't understand why it's so difficult to design a facade that actually doesn't blind people.
Yeah, you're right. Design for glare is really essential for providing comfort, visual comfort to the user. In fact, nowadays designers usually use energy as main parameter to design facade, getting totally rid of the comfort of the user.
And then?
What you can do now is just using sunglasses
Thank
to prevent
you.
glare.
That's great. Actually, I can see now. But is this the only way?
It's not the only way. So if you want, I can show you another bad example, but also the solution.
To avoid the glasses in the office.
Exactly.
Let's go.
Let's go.
Finally, I can remove the glasses.
Yes. Now I can show you the
Right.
bad design. Can you pass me the laptop?
So it's not uncommon to have the very glary scenes.
It's common. This is an example of our previous office.
All right.
So it's actually something that I lived as experience.
You were an end user.
Exactly. So this is the office. As you can see, is an open office looking south. In the facade, we have Venetian blinds in the cavity of the double glazing with the objective of redirecting back the light during summer and doing light shelf effect on the top part. And on the internal side, we have roller shades.
Okay.
So what happened is that during the summer, though, I have a very bright reflection coming from the blinds. So as you can see, there is this light here, which causes discomfort both from the visual point of view, because it was providing me glare, but also from the thermal point of view, because the light redirecting was hitting my skin and so was increasing the temperature of my body. So it was very an unpleasant sensation. So what I did is, okay, I have the roller shades inside, I can deploy them. I deployed, and what happened is that yet I have solved the problem with the thermal discomfort, but still I have the problem of the glare, as you can see from the...
Right, because the overall brightness diminished, because at least the roller blind had this effect. But what you were saying is that maybe the contrast or the direct light on the user was still too much for
Correct.
visual.
Exactly, this was the issue.
Can you avoid such a thing?
Yes, we can avoid in the design phase, because we can do modeling. So the simulation can support us in doing the correct design. In particular, Radiance allows to generate images which are very accurate, and allows you to create this luminance map and evaluate the glare, if there is. Also from using both the image, but also calculating KPIs like the DGP, so the light glare probability, which also is a standardized KPI.
So, for instance, this image you're showing, that is one of the outputs of the simulation.
Correct.
So you would do the daylight simulation, which of course takes into account the geometry, material properties, and then with the calculation you get this image where I see is in false color. What are these colors?
The luminance. So each pixel represents the luminance in that specific point.
From that point of view.
From that point of view, exactly. But with the simulation, we have to be very aware when we use it, especially according to the facade technology that we are modeling, because each shading technology has its own, let's say, peculiarity. So we need to be able to model this peculiarity in the correct way.
So, meaning that depending on the technology, the light reflectance and so on may be different, and then might be challenging to make sure that that model is representing that light distribution.
Exactly. If I want, I can show you an example of a simulation that we did. In that case, we were simulating liquid crystal glazing, so we are talking about smart glazing here. What we did was modeling this smart glazing in 3 different ways.
With the same modeling approach, with the same software, but different modeling approaches.
Exactly, of the specific technology. And as you can see from the comparison, what you can see is that there are big differences in the definition, especially of the sun resolution. And so this can give you actually a clear example of how a model cannot be appropriate for modeling the technology.
In this case, because the sun in the field of view is described in different ways, and some might be not accurate enough for that facade technology.
Exactly.
Okay.
So, in fact, this is already visible looking at the picture. So, where the sun is, in this case, distributed on a larger area and become more smaller looking at more, let's say, accurate models. But it is even more visible from the calculation of the KPI. In fact, if you look at the KPI, we can see we did this analysis in different seasons. And in December, where the sun is low, so it enters in the field of view of the user, you can see how the, let's say, simplified model underestimates the glare, while the correct model gives you actually the correct value. So you actually will have glare with this technology in that specific moment.
This bar plot shows the glare probability, the DGP, in a specific point in time of the snapshot that the simulation gave.
Exactly.
And I see that effectively only December is higher, and that only in 2 different simulation approaches you would have accounted for the right amount.
And this also affects, of course, the implementation of control strategies.
Right, yeah.
Because if you know that for that specific state of the smart glazing, you will have glare, then you will use another state instead of that one.
Dark glass, static glass.
So, simulation can help, but we have to be very aware of what model use for which technology.
And how can you make sure that, I guess, through experience and reference, you can make sure that it's the right modeling approach? How do you choose the modeling approach?
That's a good point. First of all, the experience. So the more you model the system, the more you know each model outperform with different technologies. The other option is to ask on the forum of Radiance, where you will for sure find answers
of other experts.
Or exactly, because there are a lot of experts discussing on the forum, and usually I usually use the forum quite a lot when I have doubts.
It's a good educational resource. Yeah.
It's super useful, yeah.
And I think that when there is very new facade or is very challenging, it's also in this field a thing to do empirical calibration or validation of a simulation result, or?
Yes, also the measurement of glare, I would say it's very, very important, especially also combining simulation and measurement, because with simulation, perhaps you can check a lot of technologies in a first phase, then you choose the most promising one, and then you can, always in the design phase, check with measurement which fits better your facade. And this is actually can be done with performance mockup or visual mockup that usually are built for big buildings is common. So
also to check architectural.
It can be a part of the architectural aspect, also choosing the correct, for example, internal roller shades, the correct color. So with a very easy approach, you can go on site, install the system on the performance mockup, and do the measurement.
Can you show me how to perform this measurement?
Of course. Should we go back to the bright room?
Then let me grab the sunglasses. I might need them. You measure measurements that sometimes simulations are not enough, and it would be good to go on site or let's say go to the prototype and do some assessment, empirical assessment. So let's imagine I want to measure the glare risk of a person sitting here in this bright office. How would you do it?
Okay, so first of all, we need the camera.
Do you have one?
Yes, I have it.
Nice.
Okay, so
We remove the chair, right?
correct, because what we are going to do is simulate the point of view of the user sitting at this desk. So the camera is in a position that represents the head or the eye of the user. We have a very standard camera for this analysis. What is peculiar is the lens that we are using, because it's a fisheye lens with an aperture of 180 degrees, which simulates the field of view of a human eye.
Okay.
Actually, the human eye is a little bit lower in terms of aperture, but still is very close.
I guess it's conservative because if this angle is larger, then it means you even capture more light.
Correct. Then, together with the camera, we need also an acquisition system where all the magic happen, in the sense that we have a software which acquire the image at different exposure. So we combine this image at different exposure to create an HDR image.
So the high dynamic range, the HDR you mentioned, it's important because we want to capture as much as possible all the range of light in the scene. Is it that?
Correct.
Okay.
Exactly. And then this image is post-processed in the software, in the sense that it is calibrated according to some calibration which are related to the camera, but also to some measurement that we did indoor previously. And thanks to the calibration, what we have in the end is a luminance map of this, from this picture, out of this picture, which at each pixel corresponds the energy in that pixel. So if you use, for example, the fast color on this image, we can get really well, we can spot where is the glare source or where are the brighter spots.
Right.
On top of this, the software also can calculate from the picture the KPI like the GP. So we have the image, we know where is the source, the glare source, and we also get the quantification of the glare that we have in that moment.
Depending on the metric we want to use.
Exactly.
So this image is effectively the image we get from the point of view of the user, but thanks to this calibrated method, each of the pixel is the luminance from this point of view. So you can either see how all the luminance is distributed in the field of view, or actually then compute across the image all the correlation between these different spots, and then you can have a measurement of contrast, of glare issues,
Exactly.
and then you use software, yeah.
And of course, each image is a point in time. So if you want to measure for the whole day, what we usually do, for example, is measuring at a time step of 10 minutes from according to the schedule of the office, for example, so from 9 to 8 to 6 in the afternoon. So in the end, combining all the single moment of the day, you can also draw a trend line of the curve of the glare that you have during that specific day, according exactly to your technology. So thanks to this, you can also apply, for example, new shading system inside, for example, internal roller shades, and then you can do another measurement and compare the results comparing with and without technology.
So you can compare technologies, or okay, I guess that of course you wouldn't do measurement for a whole year. You could if you have the equipment, but the thing is that we can have more than one snapshot in time.
Exactly.
That facade state or situation.
Yeah.
And my last question, you mentioned calibration.
Mm-hmm.
I guess that you, in your own control system of the measurement, you've done the photometric calibrations, if I remember well. Otherwise, manually, what would be the approach?
So let's say that there are a long list of things to take into account for the calibration. But let's say the main aspects to be considered are the absolute calibration, which basically relates the pixel. What we do is measuring with the luminanceometer one point. We compare that point with the picture, so the same pixel, and we do a offset of the data to scale exactly according to this, and this is the absolute calibration. The other important thing is related to the lens itself, because there is a reduction of the luminance from the center to the peripheral area of the lens.
Right.
So what we do is compensate this reduction with a curve that we implement in the post-processing in order to have also in the perimeter area of the picture the correct number of the energy. Exactly.
And then sometimes I see people taking vertical illuminance measurement here, just to also double check that the overall illuminance at that point matches what you would calculate from your luminance image. So to be sure that there is no any weird phenomenon that it's impairing our measurement. Sounds complex, but much more clear now. Thank you.
You're welcome.